So here's the problem. Whenever the bulbs inside of a streetlight goes out, the city needs to replace them. To do this, cities need to hire contractors to do it. But the problem is the city's not sure on whether they should replace the bulb every time it goes out and just replace that one singular bulb, or go ahead and replace all 3 bulbs whenever the contractor goes out and replaces just one bulb that died, even though the other 2 are still shining. The city wants to know if it's more efficient to just hire the contractor to replace one bulb whenever one bulb goes out and replace only one bulb singularly, or if whenever one bulb goes out, they should replace all 3 bulbs even though the other 2 are still running because they're about to die anyways. The bulbs have a different cost, and also every time the contractor goes out and replaces something at the streetlight, it has a fixed cost. So how do we figure this out? We're going to build a model that's going to let us adjust the variable inputs such as the cost of the bulb or the cost of the contractor that's going to let us know which choice is better. Let's get to it. Okay, so this is roughly the model that I'm going to show you guys how to make. I'm going to try to go as fast as I can with this, but I will include directions within the Excel file, probably in text form around here when I'm editing the video. So you guys can go ahead and pause and stop where you have to, but I'm going to try to go as fast as I can through this video because I think it's going to be a bit longer than I might want it to be, so I'm going to try to rush through it a little bit. But go ahead and pause it if you want. I'll have the text files, I'll have the text on the side so that you guys know what to do. So you can pause it and whatever, but this is roughly what it's going to do. Let me explain a little bit. This is the input section where you can change the variables so that stuff on this page changes as well. This is the scenario 1 section, and then this is the scenario 2 section. So scenario 1 is the part where they change only one light bulb whenever the contract goes out to the street and changes the light bulb. And then in scenario 2, the contractor goes ahead and changes all 3 light bulbs. There. And this is the results section also. So I'm going to teach you guys how to create this from start to finish. Okay, so let's get started. I'm going to start making it from a new file so that it's easy for you guys to see where I start and where I end. So let's get started. I'm going to call this the light bulb probability problem. And that's just a title. I'm just going to go ahead and merge that. Now we're going to create the input section. And in the input section, we're going to put the pieces of the puzzle that we can change. So for example, the mean lifespan of a light bulb, we can change that. For example, the cost of the light bulb, we can change that also. We're going to put all that in there. So let's put the mean lifespan of a light bulb. And all of this is in months. You guys can clarify that also, but I'm just going to go ahead and not clarify it there. So that's the mean lifespan of the light bulb, and then the next one's going to be the standard deviation of the mean lifespan of the light bulb. And I'm using these values, 24 for the mean lifespan, and then the standard deviation is 10 because those are the numbers that were given to me inside the problem. You guys can change this to whatever you want, but these are the numbers that were given to me in the problem. And we're going to go for cost of light bulb. Cost per light bulb, let's do that. And in the problem it was $40. Cost per visit, per site visit. So this is basically the cost for every time we hire the contractor to go change one street light. And that could consist of all 3 of the light bulbs, or it could consist of just one light bulb. It doesn't matter, it's a fixed cost, and that's $200. And then measured time. And this one is basically, it's in months. It's basically saying how much time do we want to include in our calculations. So we can change this to anything. And so right now I'm going to put it at 240 months because that was given to me in the problem also. So we're going to measure this time for 240 months. You guys can change this to anything also. So I'm just going to go ahead and format that by going to this $sign and then making it better there. So now we got the inputs part done. We've got to go to the data set part. So we need to create our data set and our data model in how to pick numbers from a probability distribution curve where the light bulb's mean is 24 right here, and then the standard deviation of that is 10. So how do we do that? So let's call this probability distribution of lifespan. So this is the probability distribution of the lifespan of the light bulb, and I'm gonna put that right here. I'm gonna put it off to the side because I'm gonna be doing all my data stuff over here. It doesn't really matter where you guys put your stuff as long as it's organized and it doesn't mess up other things. So to do that, we're gonna use equal sign. Okay, wait, no, first, before we do. So to do that, first let's name our bulbs. Bulb 1, bulb 2, and bulb 3. So we're gonna have 3 bulbs because we have 3 slots in that place, and we're gonna just put it there. So to get a random lifespan inside the probability distribution curve of the light bulb, we need to actually use the norm inv function, and this could give us a random number inside the probability distribution curve, and it could give us many random numbers for each bulb. So we can actually just pick random numbers inside those bulbs. Now to do this, we're gonna type in norm inv, and then it says probability right there, and that's just gonna be, we're just gonna call a random number from 0 to 1, and it's just naturally from 0 to 1 automatically. So it's called rand, and then you close a parenthesis, you open it and close the parentheses, and then it's gonna want the mean, so we're gonna reference that right there, and then we're gonna want the standard deviation, we're gonna reference that right there, close the parentheses, and there we go. So now we have a random number inside a probability distribution curve with a mean of 24 and a standard deviation of 10. And every time we hit F9, that number is going to refresh, but it's going to stay within that range. Now, we just want to make sure that this thing doesn't have any negative numbers, so we're going to create a maximum value number right there. We're going to put 0 as the maximum value that it could be, so it can never go below 0, pretty much. And then in addition to that, we actually just want to round it to the nearest whole number. So we're gonna do that, and I'm putting a comma 0 there because it just says round it to what decimal place, and that's 0. We just want a whole number. So there we go. So this function is our random number from a probability distribution curve, and we're actually gonna replicate that across all 3 bulbs. Oh, no, not yet. We're going to lock these keys right here, D5 and D6. All you have to do is put in a $sign there. So now that we've got that, we're just gonna replicate it all throughout there. Let's go for 20 rows. I'm not sure how many that is. Oh, it's 20. Okay, perfect. So yeah, I have 20 rows of random numbers now, and every time I hit F9, those numbers are going to refresh. Awesome. And now I'm gonna move this over here just to keep it off to the side a little bit more. I don't want it here. Oops. I don't want it over here. And the way I'm moving this is I'm basically just selecting everything, hitting Control X, and then clicking whatever cell I want, and Control V. That cuts it and pastes it, basically. Okay, so we've got our data set right here that refreshes every single time. Let's make our scenarios. So scenario 1, this is the scenario where basically we're just changing only one light bulb. So every time a light bulb goes out, we go and change it, but we don't change anything else. Now to do scenario 1, we're going to put in the 3 slots. We're gonna put in the 3 slots that we have in our street light. So we have the street light, and it has 3 slots for the light bulbs. And we want to make sure we get all the data for each of the 3 slots. And let's go ahead and just number this. So we have a little numbering system of how many light bulbs we have here. Okay, so we have 20 here and 20 there. Perfect. Okay, so basically what we want to find is when does every light bulb break and when do we replace it? That's what we want to find here. And to do that, okay, and we want to find that for each slot too, okay? So slot 1 and light bulb 1, slot 1, light bulb 2, slot 1, light bulb 3, on and on and on, okay? So this is slot 3, light bulb 12. And we just want to find it for all 20 light bulbs. And it doesn't have to be 20, you guys can make it more or less, but I recommend 20 or more, maybe 25 even, but I'm just doing 20. So we're gonna do the equal symbol, and we're just gonna reference that number right there. There we go. We're done with that slot. So what we did was we just clicked on that, we typed in the equal sign, and then we referenced that number just by clicking on it. Now once that's referenced, our second light bulb here is actually going to be different. We're going to put in the equal sign, we're going to add the top number, and then also add the reference below that right there. So what this basically means is our first light bulb inside of slot 1 died at month 20. That's too bad. Our second light bulb in slot 1 died at month 26. So it only took 6 months after the 20th month. Okay, it only took 6 months after the first light bulb died for the second light bulb to die. That's all it means right here. And that's our formula to make that happen. And now we can just replicate the second formula all the way down. We can probably replicate the first formula all the way there, second formula all the way there, and then replicate that all the way down. So now we have all our numbers for the light bulbs. So what this is saying, so we can click on a random number here, and boom, right there. Now we know in slot 2, our 9th light bulb died at month 230. It tells us a lot. Okay. So next we want to know how many light bulbs we've used up in this scenario. So to do that, we're just going to type in slot 1. I keep typing in sort for some reason. I don't know why. And my right arrow key is broken, so I can't use that. It's too bad. Okay, so this is the used section. I'm not gonna name it. Okay, so this is used. So if the light bulb was replaced, we want a value of 1 in there, and if it's not replaced, we want a value of 0. No. So if the light bulb is replaced before month 240 right there, we want this to show a 1. And if it's not replaced by 240 and sometime after that, we want a 0 there. So we just need to use a simple if statement. So we type in if, and we're going to use slot 1 right here. If slot 1 is greater than the measured time, so if it's greater than, we're going to display a 0, but if not, it's going to be a 1. So that should display a 1 right there, perfect. And we want to make sure to lock that D, because that's always going to stay there, but this one's going to keep changing. So let's do that, and then we can just replicate that all the way to the side and like that. Perfect. Okay, now we have slot 1, 2, and 3. Now we know all these ones right here, that's how many light bulbs we've used. So let's total them up. And to total them up, it's pretty easy. You're just gonna do equals sum, and then you're gonna take all that, boom, and then replicate it. There we go. So this row, this column right here has 11, this column has 11, this column has 11. And let's do a grand total right here. It's gonna do that plus that plus that. There we go. Or you could do a sum also. So we have 29 light bulbs replaced, and the contractor also went out 29 times to replace it. So with that, we can calculate our cost, and to calculate our cost, it's going to be equal to 31 times. So the contractor did this 31 times. He went out 31 times, and he also replaced 31 light bulbs. To do that, we're just going to do how many times he went out plus how much each light bulb costs. Because every time he goes out, he's only changing 1 light bulb, so it's just going to be a fixed cost right there. And that's how many times he did it equals, and that's our cost. Now let's go ahead and run a bunch of trials for this. Let's go ahead and press the equal sign, reference this cell. That's all it is, it's just a reference for this cell, so it's just the same one. Select this column on the left and go all the way down to how many ever trials do you want. I'm gonna pick 1,000 because that's just a solid number. So let's click 1,000 there. Okay, cool. So we selected 1,000 for the trial. Let's go to data, what if analysis, and data table. Leave the row input cell blank. For the column input cell, type in a random cell that you're never going to use. I'm not going to type in Z1 because it's kind of close to us, but you can type in like AA1 or something. I'm just going to type in AAA1 because we're never going to reach AA1. So just type that for the column input, leave the row input cell blank, press OK. And then there we go, we have our trials. And I'm just gonna go ahead and put a $sign on that. There we go. Okay, so we have all our trial runs. Now let's move on to scenario 2. So to get started with scenario 2, let's just type in scenario 2. And remember, this is the scenario where the light bulb is going to be changed if any light bulb is changed. All light bulbs. So we need to frame this out and divide it into steps. And there's not that many steps, but we need to kind of dissect the problem a little bit. So the light bulbs are changed every time any light bulb is changed. So that means that whenever one light bulb breaks, all of them are going to be changed. So actually we can just use the light bulb with the smallest lifespan, because that's the one that's going to determine when we change, and then we can just move on to the next one. So to kind of demonstrate that, I'm going to do it on Excel. I'm going to use the minimum function to get the smallest value from our data table here at the probability distribution of lifespans. So I'm going to put the equal sign, type in min, parentheses, and then we're just going to highlight this right there, and then enter. So what this is doing is basically just taking the minimum value of these three numbers. Now once we have the minimum value of these three numbers, that means we now know what time, when the light bulb was changed, okay? So the first light bulb broke at month 6, and that's when we're going to change the other two light bulbs as well. And we're just going to keep replicating that down there, and then we have our data for scenario 2. And that's all it is for scenario 2. So actually, I'm just going to go ahead and move this down there, because this is the ID number 1 right there. And this value right here is not going to be called slot 1, slot 2, and slot 3. It's just going to be called date changed. No, not date changed. Month changed. Because that's what it is. This is the month that we changed all 3 light bulbs. So how do we replicate that down there? It's not that hard. We just put the equal sign. We're going to take the previous value and then add the minimum value of the next set of numbers. Enter. And there we go. So we're just taking the previous value plus the minimum value of the next 3 numbers. And we can replicate that 20 times. Let's go all the way down. And there you have it. Now we have all the times where all 3 light bulbs were changed. And that's going to allow us to calculate how much money that we're spending on scenario 2 versus scenario 1. And to make that easier, we're just going to put a done question mark right there to see how many times we've changed it. Because every time we know that the contractor is going to get paid $200 plus $40 per light bulb, which is $120. So every time that the contractor goes out there, which is just one row basically. So every time the contractor goes out there, it's going to be $200 plus $120, which is $320. So each row you see here before 240 months is going to be $320. And we just want Excel to calculate that, so let's do an if statement. So if this value right here is greater than 240, then we're going to want to display it as 0. And then if not, 1. Make sure you lock your D key again, or it's not going to work out. There we go. So it's going to be a 1. 1 stands for every time the contractor goes out there and changes the light bulb. And then whenever it's 0, then that means that we're done measuring that period. And that just references this cell right here. Okay, so we have a lot of 1s here. I don't want to count them. Let's make it easy for ourselves. This is the total row. So let's just total it up. Sum of all this stuff. Because, oh, oops. All right, there we go. So the function is equals sum L13 to L32 right there. So that's the total. The grand total is still 12. And the cost is going to be different from scenario 1. The cost is going to be grand total right there of how many times the contractor changed it times, there we go, let's put a parentheses. It's going to be grand total times, let's put 2 parentheses. It's going to be 40 times 3 because we have 3 light bulbs every time, and then plus 200 right there. This could be simplified by just putting 320 right there instead of all this stuff, but we want our formulas to be changeable, so every time we change this stuff that we can test out new scenarios, okay? So it's important to also put these values there too. So let's enter, and there we go. We have the cost for scenario 2. And as you can see, it looks like scenario 2 is much, much cheaper than scenario 1. But let's make sure and run the trial 1,000 times. So equals this number, okay? And then we're gonna highlight that and go all the way to the bottom to row 1,000. Not row 1,000, but 1,000 rows down. And then, awesome. go back up here. Let's go to data, what if analysis, data table, and enter yet another random column. I'm not going to do AAA1 because we already used that for the first one. So let's use AAB1. And that right there, it appeared. Okay, let's go home. Let's format it a little bit. Okay, so we have our scenarios. So actually, we're pretty much done except for the results table. Okay, so let's make that real quick. Let's define what we found out. So the results in scenario 1. So we're gonna calculate like the benefit of scenario 1 or scenario 2. It looks like scenario 2 is gonna be much better than scenario 1, but let's make sure. Okay, so scenario 1 cost. This is gonna be scenario 1's average cost. And we're gonna calculate the average cost by basically just finding the average of all these numbers right there. So equals, I'm gonna take this and I'm gonna go all the way to the bottom. You guys can highlight it, or you can do Control Shift down key, okay? So we're gonna take all that, we're gonna find the average, sorry, put that in over there. So there we go. So this function is just gonna be the average of all that data highlighted. We wanna find the average of it, and it's 6,938. Let's do the same thing for scenario 2. And actually, I'm just going to go ahead and copy that first one and then put it into the second one and then change the column because that's what it is. So it's column L. I'm going to put it column L. There we go. Okay, so scenario 2's average cost is 4,819. Scenario 1 is 6,884. And you saw that change because every time we press F9, this data here changes, which also changes all this data, which then also changes all this data, okay? So that's why it changes every time. But on average, it's going to be about the same. So let's calculate benefit. And the benefit is just going to be the opposite scenario minus the scenario you're talking about, because you want to know what the benefit of the other one is from yours. So you can see scenario 1's benefit is actually negative because scenario 2 is better than scenario 1. Okay, and scenario 2's benefit is positive because it's better than scenario 1. So scenario 2's benefit is $2,100. Scenario 1's benefit is minus $2,100, which means there's no benefit. It's the negative, okay? So that's how you do it, guys. This is the technical part of how you do that light bulb probability problem. Every time we press F9, this data is going to change. There we go, there we go. And all that's left to do is kind of spice it up and make it look a little better. And I'm gonna do that now, but pretty much that's how you do the technical part of the light bulb problem. So let me spice it up now. Let's copy this and just throw it over here because it's kind of far away, okay? So I'm gonna use kind of an emo theme, okay? I'm over here, kind of make that darker. I use this, I like this theme because it makes things easier to see, much easier to see. I'm not emo or anything. No offense to those that are. Okay, so let's make that easier to see, right? And let's make this text a bit larger. Let's just make it wider then, okay? Light bulb probability, let's just make it bold, why not? This is our light bulb probability problem, let's make it bold. Scenario 1, it's right here. Let's darken that. This is scenario 1, so I'm just gonna highlight all of that. There we go, that's scenario 1. Let's differentiate this part right here. And then let's differentiate the cost too. There we go. Scenario 2, make it black, white. Change this part a little bit. There we go. What's this color? White. Okay, and you guys pretty much get the gist here. We're just kind of making it a bit easier to read on, we're just kind of making it easier on the eyes here. Okay. So now it's a lot easier to see. We can bold scenario 1, we can bold scenario 2. And since you can't really see that, we can make that a bit bigger also. And let's make this ID. We can make this maybe something big, something poppy. Yellow. Let's kind of like, you guys decide what you want to put for it. I'm just gonna make it yellow for now, just for easy purposes. Let's make that black, white. Let's bold the title here. Let's give it a dark gray background. Okay, so our little model here is looking pretty good. Let's go ahead and put cost in there also. Okay, so this is how you do it, guys. And it's important to also kind of format your document because it looks a lot better and it's a lot easier to read. If it's just numbers and stuff, no one wants to look at that, so you gotta make it look good too. And finally, to get rid of these grid lines, let's go to View and uncheck grid lines, okay? So this is the model, guys. This is how you do it. Every time you press F9, it changes, but in general, since we did 1,000 trials, it's gonna be around the same. And you guys can add different elements to this, but this is how you do the model on a basic standpoint. And make sure you rename your sheet and everything. And yep, it looks good. This is something you can turn in now. I hope you guys enjoyed this video, and be sure to subscribe. I'm gonna have more videos in the future. If this helped you out, let me know. It's cool. I can help you out with more stuff in the future. Just ask if you need help. No guarantees, but I'll do my best. So yeah, that's how you do the light bulb probability problem. Hope you enjoyed. Have a great day. See ya.